established or some other intermediary state. But listen, we see that the different programs that are responsible for the port, such as 631 for CUPS for printing, for the Internet Printing Protocol, are returned. Now, if you want to see name resolution, take off the N option. When you take off the N option, it attempts to return the names, such as TLP. This tells you the name of the host as well as the name of the protocol. We should also note that the names of the protocols come from etc services. Let's just return to the shell. In etc there is a services file which translates various ports, TCP and UDP, to names such as FTP data, FTP, SSH, Telnet, you name it. So we should just note that. Netstat uses etc services to translate ports to names, and so do many other TCP/IP related programs. We disable name resolution by using the N option, so it returns all listeners without name resolution. If you want name resolution, drop the N option. Now, how about focusing in on, and this, we should just note that this focuses on TCP listeners. How about UDP listeners? Sometimes you want to know what UDP ports your system is bound to. Netstat NULP returns all UDP listeners. Again, listeners are programs that our system is listening to, or ports that our system is listening to. In other words, ports that our system will service if we connect locally or from a remote system, versus sockets that are used for general communications, like established sockets. Let's examine the UDP listeners. Here are the UDP listeners, including syslog, which we know, port mapper, which serves for RPC services, a couple RPC listeners, CUPS, and others. So these are the UDP listeners. There is no state information because UDP is connectionless, meaning it doesn't maintain state information. TCP does. Whenever you see a listener on all zeros, it means any IP address defined on the system will accept traffic to that port. So for example, in the case of syslog, for each IP address defined on this system, syslog will accept traffic to any of those IP addresses or all of those IP addresses. So let's just note that. This means that syslog will accept traffic to any of the defined IP addresses / interfaces on the system. That's what the all zeros mean. There are ways to tweak, however, for security purposes, and we'll show you in the security section, services so that they don't bind themselves to all IP addresses. And this is possible with most, if not all, TCP/IP compliant operating systems. But just bear that in mind that if you are running syslog and you see all zeros, or any service for that matter, such as CUPS, for any IP address defined, which you can tell using ifconfig, and in this case it's 192.168.75.10 as well as 127.0.0.1, as well as the IPv6 addresses. So for any of these IP addresses, local IPv6 or IPv4, syslog, CUPS, and other programs that are bound to all zeros, whether TCP or UDP, will accept traffic on those IP addresses. Keep that in mind from a security perspective. Now, if you want to see sockets that are in place, execute netstat. Instead of with the NTLP, for example, drop the L option. Let's give this a try from the shell. This will also return the programs responsible for those sockets. Here are actual connections, not just listeners, but connections between a given source and a given destination. For example, this shows us that from our local system, 192.168.75.10, on a high port of 56,406, we have an outbound established SSH socket to Linux CBT Media 1 or 192.168.75.100 on its SSH port, and the session is established. We also have an SSH session, in fact, 2 SSH sessions established on the other Red Hat Enterprise system. We also have, as you can see below, an IPv6 session established for SSH back on our local system. So from the remote system, there's an SSH session back to our local system using IPv6. So executing netstat with the NT option or NTP option returns established connections or sockets. This tells you what's currently connected on your host. That's very important, as you can tell who's connected. Let's say you need to administer the system and you need to take a service down like SSH. You'd use netstat NTP to determine if there are any SSH sessions. Now, no need to look at all of this output, just grep 22. And you'll see only instances of 22, so this tells you what's going on in the world of SSH on the box. And then you'll need to make the determination as to whether or not the sessions are outbound or inbound. Whenever you see traffic terminating on your local 22, that means it's inbound. Whenever you see traffic terminating on a remote system's 22, in other words, an IP address for a system that doesn't belong to your system, then it means the session is outbound. And then you'll be able to make the determination as to whether or not you can take down your service. So that's why you use the netstat command. There's another useful command, the address resolution protocol command. This command resolves layer 2 of the OSI model, MAC addresses, to layer 3 of the OSI model, IP addresses. There are 2 different addresses in the OSI model. However, MAC addresses or layer 2 addresses are burned in or uniquely identified or associated with network interface cards or NICs. We can return this information using ifconfig. So task includes examine MAC addresses using ifconfig and ARP. Now, before we do so, let's just return to the graphic to explain what happens. When we decide from our Red Hat Enterprise 5 box, this system, Linux CBT Serve 1, to initiate a connection, let's say outbound to the Debian box or outbound to another Linux box, our system uses layer 3 of the OSI model or an IP address to communicate with that remote host. So in our SSH session out to, let's say, the SUSE Enterprise box with the 100 address, we've used 192.168.75.100 IP version 4 address to communicate. However, hosts really communicate at a lower level of the OSI model, layer 2. And each host has a unique layer 2 address. It's a 48-bit MAC address. Again, that address is uniquely identified or assigned to the network interface card or cards plugged into the box. So in fact, an IP version 4 address as well as an IP version 6 address is just an overlay or an abstraction or a topical or another way of referencing a system that's human readable or makes more sense or is more logical and allows for hierarchy. In other words, the distinction between an internal versus a DMZ versus an internet network. So indeed, our applications communicate initially using named then IP addresses, but all resolution comes down to the MAC address. And that's why it's important to know the MAC address or know how to get information about the MAC address of your local system and remote systems. But of course, all this information is taken care of for you and maintained for you using ARP. So when we make a request from our system to the SUSE Enterprise 10 box with the 100 address, an ARP request is made by the IP stack, which translates 192.168.75.100 to a distinct MAC address. Then communications proceed based on those MAC addresses. And ditto for connecting out to the DMZ or remote subnets like the internet. When we attempt to communicate, let's say, with a DMZ host, we attempt, or the IP stack translates the IP address to a MAC address. But if the IP address is on a remote subnet, then the MAC address of the network interface of the router that's connected to our subnet is stored in our ARP table. ARP takes care of this for us. It's a service provided by TCP/IP, but we should still know how to get access to that information. So first and foremost, let's examine our MAC address using ifconfig. This returns our local MAC addresses. We'll return to the shell and then execute ifconfig. Now for each network interface, ETH0 and loopback, you'll see different information. But the interface that actually communicates using MAC addresses out onto the network, whether on the local network or a remote subnet, is one of your routable interfaces, such as ETH0, Ethernet 1, Ethernet 2, and so on. ETH is short for Ethernet. LO is short for loopback. So ignore the loopback interface. This interface is always used locally, and focus on your Ethernet or token ring or other types of interfaces like PPP, your routable interfaces. Notice that this Ethernet interface, ETH0, which is the lone routable Ethernet interface in this box, has a hardware address. This is also the MAC address. Has a hardware address of the following. In fact, let's just copy the entire line. And this MAC address represents the layer 2 address of the system. So we see the output, ifconfig returned, and it returned, again, the fact that the encapsulation is Ethernet for the interface, and it has a hardware address, which is the MAC address of the 48 bits that you see here. Each of these sections represents 8 bytes. Each half represents 4 bytes, or a nibble. So 4 bytes, and if we count the sections, there are 6 sections times 8 equals 48 bits. This MAC address, this full 48-bit representation, or 6 bytes, is unique to our network interface card. And when we communicate with our local system using its routable IP address or Ethernet 0, or with a remote system using its Ethernet interface, there's a translation between IP addresses and MAC addresses, which is why we use the ARP command to reveal the values stored in that table. But it's maintained automatically for us, and very seldom will you need to actually hardwire entries. The ARP table is updated dynamically, so that means if you don't communicate with a host for a certain amount of time, then the entry will be removed until subsequent communications are attempted. Here we see an entry for 199. This is one of our SUSE box, well, one of our Linux boxes, a Red Hat Enterprise box, that is. Its MAC address is the following, and it's accessible via Ethernet 0. Here's another Linux box at 101. Or this, in fact, this is a Windows box at 101, which has a distinct MAC address. Here's the router's IP address, .1, and it also has a distinct MAC address. We see an incomplete entry for Linux CBT Deb2 because it's currently not turned on for an IP address of .175. And we see an entry for Linux CBT Media 1. Wherever possible, name resolution takes place. So here's the layer 4 information, Linux CBT Media 1 for its IP address, which translates to its MAC address. But no need to believe the MAC or the ARP table's entries. Connect to the host and examine for yourself. So for example, for this 199 host, which is a Red Hat Enterprise box, we should still have an SSH session open to it, and we do. That's here. Let's clear screen and execute ifconfig. We will see that the MAC address terminates with 1692. Let's see if that's the case here. There it is, 1692. So our local system knows how to get to 192.168.75.199